They are fast. They are strong. And the color of Orange Crush. These machines were created by Kiva Systems, a Boston area startup that wants to reinvent the warehouse business using robots. Lots of robots. Kiva's idea is simple. By making inventory items move instead of the workers, they can fulfill orders faster. In Woburn, Massachusetts, Kiva set up a warehouse to demonstrate the system.
Once I submit that order in, it understands that I'm ready to fulfill that order. So it prints out a label for that order. I build a box that I want to put that order into, and it asks me where I want to place that order onto my shelf. I'm going to say right here. Now that I've placed that order on here, and I can place up to 6 orders at a time, the system is going to go out, find that inventory, and you can see it's already starting to bring that inventory over to me, so that I don't have to go and find that inventory. It goes in, and the inventory comes to life and starts coming directly to me. So the user doesn't have to walk around, the user doesn't have to go find the orders, and it actually increases the accuracy of the orders because it's bringing me the direct inventory necessary.
A central computer keeps track of the location of each robot and piece of inventory at all times. The computer works both as a dispatcher and a traffic controller, routing the robots to their destination while preventing collisions on the floor. A Kiva warehouse can also self-organize. The central computer tracks high and low selling products and stores them accordingly, keeping popular items near the packing station and moving less popular inventory to the back of the warehouse or mezzanines.
There's a laser beam above me that's pointing directly to the bin, so I know exactly what I have to be able to go and pick. Once I pick the order and scan the barcode to validate that I have the right thing, it flashes the light and tells me which order I have to go fulfill that into. I drop that in there, and I turn around and I have another piece of inventory ready for me to fulfill.
The robots navigate the warehouse by pointing cameras at the floor to read barcode stickers. They also constantly share sensory information so that over time they adapt to warehouse nuances, like small dips on the floor or misaligned stickers. It's the wisdom of the crowd, a crowd of robots. The lifting mechanism is a custom-built ball screw powered by a single DC motor. To keep the rack motionless, the robot rotates its wheels in the opposite direction at the exact speed of the screw.
Once I'm done with the order, the system will tell me that the order is completed. It'll highlight this in red and tell me to go push it back onto the conveyor. And if there's another set of orders, it would have me fill in all my racks, so I could actually probably be working on 5 to 6 orders simultaneously.
Kiva's customers include online shoe store Zappos, drugstore chain Walgreens, and the office supply giant Staples, which has just equipped an entire warehouse in Denver with a robotic system. At the customer sites, the robots work tirelessly, stopping only now and then for a battery charge, and sometimes a nap. For Spectrum Online, Americo Rizzo.
Kiva Systems make robots that can replace warehouse staff. Once products arrive at a warehouse, robots are ready to fetch goods and deliver them to the warehouse's picking stations. The robots find and move the correct racks to the correct station for restocking. Once a robot arrives at a picking station, the system will indicate to the worker which item is to be picked and which box it should be placed in for shipment. As each truck arrives, robots are ready to unload goods.
In the video show, the warehouse used the machine were increased by Kiva Systems. Kiva Systems is a company that makes order fulfillment systems that use mobile robots for warehouse automation. The machine will walk around to keep the shelves, follow the position by read barcode on the floor. It can receive goods, case replenishment, picking station, shipping station, etc. It helps to keep product repeatedly.
Between bot and human. If they have 10 robots, amount label 100 human. So if these 10 robots work in first warehouse, you will see that areas of warehouse have increased area for keeping products, and second warehouse has 100 employees, so there's no area for keeping product.
Is comparison between robot and human. The robot will have more warehouse area and it can keeping product more than human. But robot walking use more electric power, then warehouse more expense for electric power.
This is example label between robot and human. The robot, if robot have 10 robots, will amount label of 100 humans. If robot disappear one robot, it will work only 90%. If human sick one human, they can work 99%. So the use of label between robot and humans must be appropriate to the condition of work.
Effect of labor. If in the future we bring labor of machine and technology replacing humans, so that to affect the unemployment rate of the labor intensive, but will result in a return to the workforce of engineers is increasing. For example, to the following chart. The first chart shows that there is demand for mechanical engineering technology makes engineer more, but general labor is decreasing.
Economic. The chart shows that there is demand for the product. Every product that they have increased produce the product and affect to resource. Finally, effect of resource. When they bring resource to use for the produce the product, then affect that result decreasing. For example, the following chart